Maven. In Maven, now we are focusing on Maven. Maven. Here you can see Apache um Maven internal design architecture. This is Maven 4.x. Apache Maven is a project development, management, and comprehension tool based on the concept of a project object model. Builds, dependency management, documentation creation, site publication, and distribution publication are all controlled from the pom.xml declarative file. Apache Maven can be extended by plugins to utilize number of other development tools for reporting and build process. Here is a diagram that shows the internal design architecture of Apache Maven. Apache Maven modules are labeled in this colored boxes, and third-party modules are labeled in uncolored boxes here, and this one also. Here you can see a distribution. Distribution is connected to SLF4J-provider SLA, and it is connected to SLF4J-wrapper, and also distribution is connected to embedder, and you can see here BOM, and embedder is connected to SL4J-wrapper and also connected to compact, and compact is connected to core, and core is connected to plugin -mp API, and core is connected to toolchain builder, and settings builder, and resolver provider. Toolchain builder is connected to toolchain model, and settings provider is connected to settings builder support, and and model builder is connected to builder support, and also connected to model transform and model and artifact. And here resolver provider is connected to repository metadata, and you can see here embedder is connected to commons CLI, and SL4J-wrapper is connected to SL4J API, and core is connected to shared utils, and shared utils is connected to Jansi, and plugin API is connected to Sisu, and inside it you can see a plugin API is connected to Perplex, and in Sisu you can see Plexus and Inject. Plexus is connected to Inject. Inject is connected to Juice, and Plexus is connected to class words, and inside the Plexus you can see class words, interpolation, sec dispatcher, cipher, and utils. Toolchain builder, settings builder, and model builder are connected to interpolation. Settings builder is connected to sec dispatcher, and resolver provider is connected to IMPL. Inside the resolver you can see IMPL, SPI, API, and util. IMPL is connected to SPI and util. SPI is connected to API, and util is connected to API. Here you can see a standard Maven directory layout. Having a common directory layout allows users familiar with one Maven project to immediately feel at home in another Maven project. The advantages are analogous to adopting a site-wide look and feel. Try to conform to this structure as much as possible. However, if you can't, these settings can be overridden via the project descriptor. Here you can see source main Java application and library sources. Here you can see source main resources. This is application library or library resources. Here you can see source main filters, resource filter files, and you can see source main web application sources. And here you can see source test Java test resource test sources, source test resources, test resources, and source test filters, test resource filter files. Here you can see source IT integration test, primarily for plugins, source assembly descriptors, source site, and you can see and top level you can see you can find license.txt project license, notice.txt notices and attributions required by library and that the project depends on, readme.txt projects readme. At the top level, files descriptive of the project, a pom.xml file. Basically, at the top level, the file descriptive of the project, a pom.xml file. In addition, there are textual documents meant for the user to be able to read immediately on receiving the source. Readme.txt, license.txt, etc. There are two subdirectories of the structure, src and target. The only other directories would be expected here are metadata like cvs.git or .svn and any subprojects in multi-project build, each of which would be laid out as here. As previous directories for metadata. The target directory is used to house all output of the build. The src directory contains all of the source material for building the project. Its site, project, its site, and so on. It contains a subdirectory for each type. Main for the main build artifact, test for the unit test code and resources, site, and so on. Within artifact producing source directories, main, that is main and test. For the main, there is one directory for the language Java, under which normal package hierarchy exists. and one for resources. The structure which is copied to the target class path given given the default resource definition. If there are other contributing sources to the artifact build, they would be under other subdirectories. For example, source main ANTLR would contain ANTLR grammar definition files. Here you can see a directory layout, project folder, then source and target. Then it's under source there are main, test, IT, and assembly and site. Under main there are Java resources, a web app, config, script, and filters here in this diagram. Under test, Java resources and filters here. Here you can see Maven life cycles and paces. Dark ones are the frequently used. Here you can see the all build paces of the default, clean, and site life cycles, which are executed in the order given up to the point of the one is specified. Here you can see clean life cycle, pre-clean, execute processes needed prior to the actual process cleaning. Clean pace, remove all files generated by the previous build. Post clean, execute processes needed to finalize the project cleaning. Here you can see default life cycle. Here you can see validate the project is correct and all necessary information is available. Here you can see the pace initialize build state. For example, set properties or create directories. Here you can see generate sources. Generate any source code for inclusion in compilation. Paste process sources. Process the source code, for example, to filter any values. Generate resources for inclusion in the package. Process resources, copy and process the resources into the destination directory ready for packaging. Compile the source code of the project. Paste here the process classes. Post process the generated files from compilation, for example, to do bytecode enhancement on Java classes. Generate test sources. Generate any test source code for inclusion in compilation. Process test sources. Process the test source code, for example, to filter any values. Generate test resources. Create resources for testing. Process test resources. Copy and process the resources into the test destination directory. here you can see process test classes. So in this diagram, one process is missing, is called test compile after test process test resources. In test compile the test source code into the test destination directory. Then process test classes. Post process the generated text generated file from the test compilation. For example, to do bytecode enhancement on Java classes, the paste test, run test using a suitable unit testing framework. These tests should not require the code be packaged or deployed. Prepare package. Perform any operations necessary to prepare a package before the actual packaging. This is often result in an unpacked processed version of the package. Take the compile code and package it in its distributable format, such as a jar. Pre-integration test. Perform actions required before integration tests are executed. This may involve things such as setting up the required environment. Integration test. Process and deploy the package if necessary into an environment where integration tests can be run. And there's another page called post integration test. It's not shown here. Perform actions required after integration tests have been executed. This may include cleaning up the environment. And then verify. Run any checks to verify the package is valid and meets quality criteria. Then install the package into the local repository for use as a dependency in other projects locally. Deploy done in an integration or release environment copies the final package to the remote repository for sharing with other developers and projects. Here site life cycle. The paces are here, and pre-site execute processes needed prior to the actual project site generation. Generate the project site documentation here, site. And post site execute processes needed to finalize the site generation and to prepare for site deployment. Site deploy the generated site documentation to the specified web server. And here you can see the paces. So here you can see in clean lifecycle, pre-clean is connected to clean, and clean is connected to post-clean. In default lifecycle, validate is connected to initialize is connected to generate resources, and it is connected to process resources, and it is connected to generate initialize is connected to generate sources. Generate sources is connected to process sources. Generate and process sources is connected to generate resources. Generate resources is connected to process resources. Process resources is connected to compile. Compile is connected to process classes. Process classes is connected to generate test resources. Generate test resources is connected to process test resources. Process test resources is connected to generate test. process classes is connected to generate test sources. Generate test sources is connected to process test sources. Test sources is connected to generate test resources. Generate test resources is connected to process test resources. Process test resources is connected to test compile. It's not shown here. Test compile is connected to process test classes. Process test classes is connected to test. Test is connected to prepare package. Prepare package is connected to package. Package is connected to pre-integration test. Pre-integration test is connected to integration test. Integration test is connected to post-integration test, not shown here. And post-integration test is connected to verify. Verify is connected to install, and install is connected to deploy. In site lifecycle, pre-site is connected to site, and site is connected to post-site, and post-site is connected to site deploy. As an example, we can consider this one, Maven clean deploy. In a build environment, use the following command to cleanly build and deploy artifact into the shared repository. Here, the paste clean remove all files generated by the previous build, and in the paste deploy done in an integration or release environment, copies final package to the remote repository for sharing with other developers and projects. As an example 2, we can consider this one, Maven compile test compile. This is compile is plugin, and this is the goal, and this is called the paste test compile. This compile the test source code into the test destination directory. Here this is regarding packaging. The first and most common way is to set the packaging for your project via equally named POM element packaging. Some of the valid packaging values are Java, EAR, and POM. If no packaging value has been specified, it will default to jar. Each packaging contains a list of goals to bind up to a particular page. Here we are considering the default to jar. As an example 3, we can consider this one, configure plugins. The second way to add goals to pages is to configure plugins with your project. Plugins are artifacts that provide goals to Maven. Furthermore, a plugin may have one or more goals wherein each goal represents a capability of that plugin. For example, compiler plugin has two goals, compile and test compile. The former compiles the source code of your main code, while the latter compiles the source code of your test code. Goals that are configured will be added to the goals already bound to the lifecycle from the packaging selected. If more than one goal is bound to a particular page, the order is used is those from the packaging are executed first, followed by those configured in the POM. Note that you can use executions element to gain more control over the order of particular goals. For example, here the Modelo plugin binds by default its goal Modelo Java. To the generate sources page, Note that the modulo :java goals generate Java source codes. So to use modulo plugin and have it generate sources from the model and incorporate that that into build, you would add the following this to your POM in the plugin section of build. You might be wondering why executions element is there. That is so that you can run the same goal multiple times with different configurations if needed. Separate executions can also be given an ID so that during inheritance or application phases during inheritance or the application of profiles, you can control whether goal configuration is merged or turned into an additional execution. When multiple executions are given that match a particular phase, they are executed in the order specified in the POM with inherited execution running first. As an example 4, we can consider this code segment related to profile activation. This is in file settings.xml. Profiles can be explicitly specified using stroke dash p command line flag. This flag is followed by a comma delimited list of profile IDs to use. Profiles specified in the option are activated in addition to any profiles which are activated by their activation configuration or the activation profiles section in settings.xml. From Maven 4 onward, Maven will refuse to activate or deactivate a profile that cannot be resolved. To prevent this, prefix the profile identifier with an question mark, making it as optional. Here you can see the command here. Profiles can be activated in the Maven settings via the activate profiles section. This section takes a list of active profile elements, each containing a profile ID inside. Profiles listed in active profiles tag would be activated by default every time a project uses it. Here there are two examples of POMs share a common dependency and each has non-trivial dependency. This information can be put in a parent POM like this. This is the parent POM. The dependency management section is a mechanism for centralizing dependency information. When you have a set of projects that inherits from a common parent, it is possible to put all information about the dependency in a common POM and have simpler references to the artifacts in the child POMs. You can see the here group ID A, and here excluding C, exclusion C, and here group ID C, and here group ID A. So this is the parent form. As an exception example, we can consider this one occurred in environment with Sonar scanner for Maven. Here you can see scanning pro project and etc. And here you can see Apache org.apache.maven.exception, default exception handler, get message here, and etc. As an error example, you can see here build failure and fail to execute goal org.apache.maven.plugins Maven archetype plugin 2.1 generate default CLI on project standalone POM directory. My app already exists. Please run from clean directory, etc. Here as an additional example, we can consider Maven OPTS, Maven underscore OPTS environment variable. This variable contains parameters used to start up JVM running Maven and can be used to supply additional options to it. For example, JVM memory settings could be defined with the value -xms 256m and -xms 512m. Now we are considering package org.apache.maven.api here. Now we are considering the class default Maven in package org.apache.maven. Here you can see the we are considering CLI Maven CLI options reference. You can see the option -am or -- also -make. If a project list is specified, also build project required by the list. Now we are considering running the core ITs in Maven core ITs. By default, the project just packages the test in an artifact. To actually run them, activate the run-its. This will subject the Maven version running the build to the integration tests. If you would like to test the different Maven distribution, you can also use the Maven home system property to specify the path of the Maven distribution to test, like here. Alternatively, you can just specify the version of the previously installed or deployed Maven distribution, which will be downloaded, unpacked and tested, unpacked and tested. To run it, IT is using embedded Maven 3.x. Additionally, activate the embedded profile. ITs that don't require to fork Maven can also run from the IDs using Maven project from the workspace if the Maven dependencies are added to the test class path. If you are behind a proxy, use the system property proxy.host or proxy.port, proxy.user, proxy.pass, and proxy.non-proxy host to specify the required proxy setup for the ITs. Alternatively, set the system property maven.it.central to a URL of a local repository manager, anonymous authentication only, that proxies the required artifacts. Now we are considering artifact types. Here the archetype artifact IDs Maven archetype the archetype to generate a sample archetype. Here you can see the maintained by the Maven project in available extensions. Here you can see the extension build cache. It's a Maven incremental build and cache, local and remote. Here the version we are considering version 1.0.0. The open source in outside Maven land, the extension notifier, a status notification will be sent at the end of the Maven build. Now we are considering available plugins. There are built and reporting plugins. Maven is at its heart the plugin execution framework. All work is done by plugins, looking at for a specific goal to execute. Build plugins will be executed during the build, and they should be configured in the build element from the POM. The reporting plugins will be executed during the site generation, and they should be configured in the reporting element from the POM, because the result of reporting plugin as is part of generator site. Reporting plugin should be both internationalized and localized. You can read more about localization of the Maven plugins and how you can help. Now we are considering core plugins in supported by Maven project in available plugins. Here you can see plugin clean up after the build. With regarding the API, the field public static final lifecycle phase clean in enum lifecycle phase in package apache.maven.api.plugin.annotations. Now we are considering retired. Here the plugin and generate and build file for the project. This is type in the type build and the version 2.10. Outside the Maven land, here the at Mojo host, formerly known as codehost.org, the plugin here the animal sniffer build signatures of APIs, JDK for example, and check your classes against them. Now we are considering creating and submitting a patch in developing Maven in the Maven Developer Center. We have a couple of guidelines when submitting contributions. The most convenient way to create a GitHub fork from the Git repository you are working with. When you have either completed or issued or just want to some feedback on the work you have done, create a pull request. We have a couple of guidelines when submitting contributions. Verify the status of the master branch on Maven CI. If it is not success, then first try to figure out the problem. Don't start with your own issue yet. You can use the Git bisect to figure out the problematic commit and help with committer to solve the problem. Create your branch from master, not from the tag. Otherwise, your patch is outdated the moment you create it and might not be applicable to the development head. If this was a new piece of work without a Jira issue, create a Jira issue for it now. Name the branch after the issue number. Branch name would start with Jira project ID ticket ID. Push your branch with the commits to your fork. Create a pull request to submit to a contribution. Shortly after, someone will review the pull request and give you a feedback on it. A short note: make sure that you follow our code style. Now we are considering why would I want to build Maven in building Maven. Building Maven or a plugin or any component yourself is for one of two reasons. To try out a bleeding edge feature or bug fix, issues can be found in Jira. To fix a problem you are having and submit a patch to the developers team. Now we are considering checking out the sources. All of the source code for Maven and its related libraries are managed in the ASF source code repositories. For details, see HTTPS this address. Now we are considering building Maven. The building a Maven plugin, no component in building Maven. Building a Maven plugin, no component is like any Maven build, like here. Running integration test before submitting a patch. It is advised to run the integration test, which are available in the run its run-its, then install. Now we are considering building Maven core. Until Maven 3.3, the Maven core build could be bootstrapped with the Ant build. This bootstrap has been removed in Maven 3.5. You need pre-built Maven to build the Maven from source. To do this, run the source directory here. The assembles will be created in Apache Maven, Apache-Maven, and can be manually unzipped to the location where you would like to the resulting Maven installed. If you want to have resulting Maven directly copied to a directory, you can use the distribution target dir property here. Running the full Maven core integration test before checking in a change or submitting a patch to Maven core. It is required to run the core integration test using your local build of Maven. Run this one here, this command. Now we are considering enable Apache servers in introduction in committers and resources. You need to tell the Maven what your Apache username is. The Maven uses several servers configuration to deploy snapshots and releases on the Apache servers. You need to tell the Maven what your Apache username is. It is highly recommended to use Maven's password encryption capabilities for your passwords. To publish a snapshot of some part of Maven, your Apache LDAP username, your Apache LDAP password. To stage a release of some parts of Maven, your Apache LDAP username, your Apache LDAP password. Now we are considering developers conventions. XML code style in XML in developers conventions. The Maven style for XML file is mainly mainly indentation. Always use two spaces indents unless you are wrapping a new XML tags line, in which case you should indent 4 spaces. Line breaks always use new line with indentation for complex XML types and no line breaks for simple types. Always use a new line to separate XML sections, so blocks, for instance. In some cases, adding comments could improve the readability of blocks, for instance, or here. Here you can see a workflow, the workflow in Maven JIT convention. Workflow for SVN fork is something like here, and more quiet workflow is like here. Fails because someone else has already pushed to master. So fails because someone else has already pushed to master, and this creates some mergers. Fails someone else has already pushed to master. This moves origin / master, and this reapplies your local changes on top of the origin / master. Here you can see introduction in making releases. Here the gpg - gen key here. gpg -- gen key. Now we are considering other resources, for example, ASF development infrastructure information. Now we are considering downloading Apache Maven 3.9.4 in Maven User Center. Here you can see the system requirements. The Java development kit Maven 3.9 plus requires JDK 8 or above to execute. It still allows you to build against 1.3 and other JDK versions by using tool chains. Memory, no minimum requirements. Disk, approximately 10 MB is required for the Maven installation itself. In addition to that, disk space will be used for local Maven repository. Size of your local repository will vary depending on usage, but expect at least 500 MB. Operating system, no minimum requirement. Startup scripts are included as shell script, tested on many earlier Unix flavors and Windows batch files. Now we are considering installation in Maven in 5 minutes. After that, type the following in a terminal or in a command prompt. The Maven is a Java tool, so you must have Java installed in order to proceed. First download the Maven and follow the installation instructions. After that, type follow this command in a terminal or in a command prompt. It should print out your installed version of Maven, for example here. Depending upon your network setup, you may require extra configuration. If you are using Windows, you should look the Windows prerequisite to ensure that you are prepared to use Maven on Windows. Now we are considering how do I make my first Maven project in Maven Getting Started Guide. On to creating your first project, in order to create the simplest of Maven project, execute this command from the command line. We are going to jump headlong into creating first Maven project. To create our first Maven project, we are going to use a Maven's archetype mechanism. An archetype is defined as an original pattern or model from which all other things of the same kind are made. In Maven, the archetype is a template of a project which is combined with some user input to produce a working Maven project. That has been tailored to users' requirements. We are going to show you how the archetype mechanism works now, but if you would like to know more about archetype, please refer to our introduction to archetypes. On to creating your first project. In order to create the simplest of Maven project, execute the following from the command line. Once you have executed this command, you will notice a few things have happened. First, you will notice a directory named my app has been created for a has been created for a new project, and this directory contains the file name pom.xml that should look like this. Pom.xml contains the project object model for this project, and the POM is the basic unit of work in Maven. This is important to remember because the Maven is inherently project centric in that everything revolves around the notion of a project. In short, the POM contains every important piece of information about a project and is essentially one-stop shopping for finding anything related to a project. Understanding POM is important, and new users are encouraged to refer introduction to POM in the user manual in documentation. This is very simple POM, but it still displays a key element every POM contains. So let's work through each of them to familiarize you with the POM essentials. The project, this is a top level element in all Maven pom.xml files. Model version, this element indicates that version of the object model this POM is using. POM version of model itself changes very frequently, but it is mandatory in order to ensure stability of use if and when the Maven developers seem it necessary to change the model. Group ID, this element indicates the unique identifier of the organization or group that created the project. The group ID is one of the key identifiers of a project and is typically based on the fully qualified domain name of your organization. For example, logo repository of Maven plugins is the designed group ID for Maven plugins. Artifact ID, this element indicates the unique base name of the primary artifact being generated by this project. The primary artifact for a project is typically a jar file. Secondary artifact is like bundles also use the artifact as part of their final name. Typical artifact produced by Maven would have the form artifact version and the extension. For example, myapp-1.0 .jar. Version, this element indicates the version of the artifact generated by the project. Maven goes a long way to help you with the version management, and you will often see the snapshot designer designator in the version which indicate that the project is in a state of development. Name. This element indicates the display name used for the project. This is often used to Maven generated documentation. URL. This element indicates where the project site can be found. This is often used Maven generated documentation. Properties. This element contains value of placeholders accessible anywhere within the POM. Here the name. Name. This element indicates the display name used for the project. Here. This is often used in Maven generated documentation. And URL. This element indicates where the project site can be found. This is often used in Maven generated documentation. Properties. This element contains value placeholders accessible anywhere within the POM. And the dependencies. This element's children list dependencies. The cornerstone of POM. Build. This element handles things like declaring your project's directory structure and managing plugins. For complete reference of what elements are available for use, POM page refer to our POM reference in documentation. Let's go back to the project at hand. After archetype generation of your first project, you will also notice that following directory structure has been created. As you can see, the project created from the archetype has a POM, a source tree for your application sources, and source tree for your test sources. This is the standard layout for Maven project. Application sources reside in base directory /source /main /java, and test sources are in base directory /source /test /java, where base directory base open curly base dir close curly base represent the directory containing pom.xml. If you are creating Maven project by hand, this is the directory structure that we recommend using. This is the Maven convention. To learn more about it, you can read the documentation. And now that we have POM, some application sources and some test sources, you are probably asking. Now we are considering request a new Jira account and submit an issue in getting help. This is so what we can communicate with you while we work together on the issue. Requesting a Jira account is preferred if you are planning to contribute the project by coding or testing by longer time. This is so that we can communicate with you while we work together on the issue. Please use your real name and the surname if possible in public name field. Links to your public projects, social and professional profile can be appreciated. You can also tell us a little about yourself and what you intend to use this account for. Such information is useful to verify that account is requested for real user, not a bot. Now we are considering what is a plugin in Introduction to Maven Plugin Development in Plugin Developer Center. The Maven Clean plugin is responsible for removing the target directory of a Maven project. Maven is really just a core framework for collection of Maven plugins. In other words, Maven's plugins are much of the real action is performed. Plugins are used to create jar files, create var files, compile code, test unit code, create product documentation, and on and on. Almost any action that you think of performing on a project is implemented as a Maven plugin. Plugins are central feature of Maven that allow for reuse of common build logic across multiple projects. They do this by executing an action, that is creating a var file or compiling unit test. In the context of a plugin description, the project object model POM plugin behavior can be customized to a set of unique parameters which are exposed by a description of each plugin goal or mojo. One of the simplest plugins in Maven is a clean plugin. Maven Clean plugin is responsible for removing the target directory of a Maven project. When you run Maven Clean, Maven execute the clean goal as defined in the clean plugin, and the target directory is removed. The clean plugin defines a parameter which can be used to customize plugin behavior. This parameter is called output directory, and it defaults to $project open curly brace project.build.directory closing curly brace. Here you can, we are considering your first mojo in your first plugin in your guide to developing Java plugins. A simple mojo, it is a simple mojo, and this is about as simple as mojo can be. And after the listing is a description of various parts of the source. I'm going to provide some description of the various parts of the source. This class abstract mojo in Apache Maven plugin. Abstract class to provide most of the infrastructure required to implement a mojo except for execute method. The listed here is a simple mojo class which has no parameters. This is about as simple as mojo can be, and after listing the class Apache, here the class up org.apache.maven.plugin.abstract mojo provides most of the infrastructure required to implement a mojo except for the execute method. The annotation at mojo is required and control how and when the mojo is executed. The execute method can throw org.apache.maven.plugin.mojo execution exception if a problem occurs. Throwing in this exception causes build failure message to be displayed. The getLog method defined in abstract mojo returns a log-like logger object which allows plugin to create messages at levels of debug, info, worm, and error. This logger is the accepted means to display information to the user. Please have a look at the section, look at the documentation for more information. All mojo annotations are described in mojo API specification. Here says hi to the user. Now we are considering how it works in introduction. A regular Maven project usually invokes the reporting goals of a plugin by declaring such plugin in the reporting section of the pom.xml as in this example here. When Maven site plugin is invoked, for example Maven site command, the specified plugins are loaded and generate the method of each Mojo class that implements Maven report is executed. The generate method generates a document through the Maven Doxia sync API. This document is comprised of basic elements like title, heading, text, links, label, etc. This is where you will put the logic of your report assembling element based on the content of the Maven project. This document elements are passed to Doxia to generate HTML document, which itself gets wrapped into a Maven skin as specified in the projects .source/site/site.xml. The result produces an HTML file in the ./target/site directory of your project. Here you can see unit tests. Here you can see Maven plugin testing harness in unit test in testing your plugin. The abstract, you can see the class abstract Mojo test case in package Maven.plugin.testing. The Maven plugin testing harness is explicitly intended to test the Maven.reporting.abstract Maven report execute implementation. In general, you need to include Maven plugin testing harness as a dependency and create a Mojo test. By convention, the class extend the abstract Mojo test case. Required for Mojo lookups to work. Sorry, here. Here you can see verify plugin documentation in documenting your plugin. The Maven docck plugin can be run here. The Maven docck plugin checks that the project compiles with the plugin documentation standard. You should verify that all plugin documentation respects this standard. The Maven docck plugin can be run here. Now we are considering introduction in the Mojo API. Although the requirements on Mojos are minimal by design, there are still very few requirements that Mojo developers must keep in mind. Maven plugins can be written in Java. These are the things, and the Maven plugin can be written in Java or any other number of scripting languages. Plugin consists of one or more Mojos, each one being the implementation for one of the plugin goals. Note this document plugin goals. Although the requirement on Mojos are minimal by design, there are still very few requirements that Mojo developers must keep in mind. A Mojo can have a method named execute which declares no parameters and has a void return type. If this method throws an exception, that exception must either be a derivative of java.lang runtime exception or a derivative of apache.maven.plugin.mojo execution exception. It goes without saying that in the letter case, the execute method must declare that it throws this exception. Additionally, Mojos must declare a field for each goal parameter they specify, and these parameter fields will be populated before execute method is called. Finally, all Mojos must be accompanied by metadata in meta info /maven/plugin.xml describing parameters lifecycle bindings, etc. This descriptor will be covered in more. You can get more information on these descriptors in documentation. Now we are considering configuring logging in Maven 3.1.x logging. Every entry in this file can be overridden via Maven's JVM system properties by using the D flag, -D flag in Maven _ OPTS, for example. To configure the logging with SL-F4J simple, you can edit the properties in the $maven.home /config /logging /simple logger.properties file. Please see the linked reference of documentation for details. Every entry in the file can be overwritten via Maven's JVM system properties by using the -D flag in D with -D flag in Maven options here. For example, here you can see this Maven this one thread name equal true, and Maven goals will add the thread name to every logging line. This will add the thread name to every login line, and this will add the logger name to every login line. The default SL4J configuration for Maven is listed in the documentation, where you can see other useful property names to customize logging. Now we are considering build your extension in Maven 3 lifecycle extensions. Here, the create your extension class. Your extension must be a Sisu component. Therefore, mark it with the JSR 330 for all legacy plexus contain annotation. Here, the class abstract Maven lifecycle participant in Apache Maven allows core extension to participate in the Maven build session lifecycle, and allow all build will pass before XXX and after XXX naming pattern to indicate what at what lifecycle point it is being called. Here the and after here. To create a Maven project with dependency on org.apache.maven :maven-core colon 3.9.4 and other dependencies. Here the Maven core here. Create your own extension class. Your extension must be a Sisu component. Therefore, mark it with JSR 330 or legacy plexus container annotation. Generate Sisu index files during the build of your extension jar. Always provided by the Maven core class loader. Dependency for the JSR 330 annotation. Always provided by the Maven core class loader. Start BM machine. ask beer to the machine. Here you can see the receipt for in how to upgrade the Plexus Java doc text to Plexus Java annotations. In your pom.xml, add the Plexus component annotations dependency. In your pom.xml, add the Plexus component annotations dependency. In your Java sources, replace Java doc tags with corresponding here the corresponding Java 5 annotations. Now we are considering how to use JSR 330 in plugins in using JSR 330 instead of Plexus Java annotations. Constructor injection. With the Plexus Lex, greatly simplified the testing. Let's take a look at an example plugin. If you want to look at this example project, you can find it in the Maven core ITs. The POM is a setup for JSR 300 300 with the java.inject dependency and java.index dependency and the Sisu Maven plugin. Configured to create JSR 330 component index. In addition, we added classical Maven plugin dependencies, Maven plugin API, and Maven plugin annotations to extend abstract mojo and use Java plugin test tools annotations associated with Java plugin plugin. Now let's look at the plugin code. You will notice that that were using constructor injection, which makes testing a lot easier. If you want to test your JSR 330 component, you do not need the container to instantiate the mojo. In this simple case, you can actually test the plugin without using plugin testing harness, because you can instantiate JSR 330 component and JSR 330 mojo directly and wire everything up manually using constructor. Constructor injection with Plexus Lex greatly simplified the testing. Say hello to the to the world my little constructor injected component. Here you can see a basic sample in Maven repository, the package with the API, the with the API we can consider the method at not null public model.builder repositories collection type parameter repositories in class model.builder in package apache.maven.api.model. Not recommended, this part. Now we are considering digging into central index with look in central index. Download and extract the look binary table and launch it on the central index with Lucene format. First, download central index nexus maven repository index.gx, download maven index CLI, and unpack the index to row Lucene index directory. Download and extract the binary table and launch it on the central index with Lucene format. You need an old Luke version using old Lucene version, since Maven index 5.5.1 uses Lucene 3.6.2 for this. But with more recent Maven index releases, more recent Lucene version have been used. Now we are considering where do I set artifact extension in Maven artifact with type handlers here above here. Maybe surprisingly the dependency to this very same artifact can be described in two ways. Maven POM, where you can declare your project parent project dependencies plugin and other, maps those elements into artifact coordinates with some extra logic. Also, this has consider for example the artifact org.project : reusable test support : 1.0 : tests jar with this type handlers. Maybe surpassing the dependency to this very same artifact can be described in two ways. And the equivalent would be equivalent dependency would be here. Obviously different is presence of classifier in the first case, while in the second lack of it, but presence of type test dash jar in the other hand implies classifier of test. In both cases extension is jar. In first it uses the default value of this property, while the second type defined it. Not in this very case. Using the first way is somewhat explicit and is recommended way. Not so far for the cases when type handle carries some important extra information like some custom packaging, where using type is more appropriate. Simply put in this case the type test dash jar is like an alias for ordinary jars with test classifier. Now we are considering the A-level metadata. In metadata, the XML bits considered for this kind of metadata are only The artifact level metadata found in directory of artifact serves purpose of version discovery. This metadata contains a list of versions of given GA coordinates and XML bit considered for this kind of metadata only. Now we are considering Maven repository layout. The layout is responsible for translating the artifact coordinates into generic path, but is later used to construct the some URL. File path URL, it depends on context. Obviously, since Maven inception in 2002, the layout evolved as well. For simplicity, we will cover current layout, also known as Maven 2 or default, as since Maven 3.x release. The deprecated Maven 1 layout, also known as legacy, is not supported anymore. This above implies following: the repository contains a file that is not on layout, does not obey layout transformation rules discussed rules. The file is not addressable by the Maven coordinates. You cannot address that file in Maven, nor make it to download it using GAV coordinates. Using some properties transformed, we can construct the following path if classifier is not present, like here. Or if classifier is present, you can use this path. So the example artifact can be noted as GAV. GAV, and is translated to path as like here. And this is that is it. This applies to this algorithm, and above any artifact can be built up path segment that artifact is expected to be. Important note in this case, in case of locally installed artifact, those you built locally and invoked Maven install will use artifact based version property instead of version. The full-blown timestamp version are used by in remote repositories when the artifact is deployed. So this is the full tar file.